In this video, we'll be talking about models for subtracting whole numbers. Now, subtraction just undoes addition, so that's why we call addition and subtraction inverse operations. But a lot of students really struggle with subtraction, so we're going to show models that will help them understand. The first one is the takeaway strategy, which is exactly what you would think it is. 8 minus 3. You have 8 blocks, and you take away 3 blocks, and then count that you have 5 blocks left. We also have the missing add-in model, which I like to call what's behind door number 1. So you have 3 plus something equals 8, and you have to figure out what that something is. Also, there's a visual aid, and you can use this under a document cam in your classroom. You have 8 blocks, but only let 3 show and put like a napkin or a handkerchief or something over the other 5, and they have to guess how many blocks are underneath your napkin. There's also the the number line visual aid. So you know you have to go to 8. You've already gone 3, so you have to figure out how long that arrow is. Again, that's another one for missing add-in. In subtraction, students are also introduced to the idea of an unknown. That's an actual algebra concept. So the definition of subtraction is for any whole numbers, A and B, such that A is bigger than B. So we know that A is the biggest number. Then we're going to subtract B from it. You get a unique number C. So let's take 5 minus 3. 5 is the bigger number. We subtract 3. This shows that we only have one answer. 2. 2 is the only answer it could be. It is unique. So I want to show you this. This is called a fact family. You may have used flashcards when you were in elementary school. Well, now we have fact families, so they're triangular flashcards, but notice that you have a lot of operations on there. First, you can show that 3 plus 5 gives me 8, but I can also show that 8 minus 3 gives me 5, or 8 minus 5 gives me 3. So basically, it's 3 flashcards in one. So that's a popular manipulative that you can use in your classroom, fact families. We also have the comparison strategy. So we're setting up a one-to-one correspondence between 2 sets. That's just a fancy way of comparing the 2 sets. So you notice we're going to set up one, we're going to figure out how Juan and Susan's blocks compare. So Susan and Juan have the same number of blocks, except Susan's going to stop, and we've got to figure out how many more Juan has. So Juan has 5 more blocks than Susan. So that's called the comparison strategy. We also have the number line strategy. So basically our arrow gets to go in the other direction. So notice our arrow right here is green. It's going in the other direction. So you know you have 5, and then you're going to subtract 3 and go the opposite direction. And then this is going to be your answer, which is going to be 2 blocks, 2 units. That's the number line strategy. Now, we talked about properties before, so let's see which properties work or don't work for subtraction. Let's talk about closure. So we have our whole numbers in a box. We need to see if it's closed under subtraction. So I'm going to grab 2 numbers, 3 and 5, and I'm going to subtract them. 3 minus 5. Notice I get a minus 2. Therefore, that is not in the box. So it is not closed under subtraction. What about the commutative property? Let's pick 2 whole numbers and see if they're commutative. So 3 minus 5, that gives me minus 2. But when I flip it, 5 minus 3, that gives me a positive 2. Those are not the same. So there is no commutative property for subtraction. What about association? The associative property. So we have our numbers. They're all in the same order. 1 minus 2 minus 3. But we're going to group them. But notice when I do that, I get 2 different numbers. So therefore, I'm not going to have an associative property for subtraction. What about the identity property? Well, at first, it looks like it might work. 5 minus 0 equals 5. So I'm getting what I started with. Started with 5, and I end with 5. But what if I reverse those numbers? 0 minus 5. That's not going to give me what I started with. So there's no identity for subtraction. One thing you might notice in textbooks today is that now we have X's in our textbook. We used to only have boxes in elementary school, but now they've started adding X's and A's and B's, letters in there, to help introduce algebra to younger students.